Another thing that you'll notice is these two angles form a straight angle. Angle 1 and 2, they form a straight angle. Another way of saying that is they both lie on a line. Or they form a line together. They form a line together. And if that's the case, well, we just talked about straight angles over here because this is a straight angle. Well, straight angles, their measurements always are 180 degrees. So we know that from here all the way and back must be 180 degrees. Well, then that means that the measurement of angle 1 plus the measurement of angle 2, plus the measurement of angle 1 plus the measurement of angle 2 must equal 180 degrees. And again, notice my notation. I had to put that M in front of it, in front of the angle symbol, because we're talking about a numerical value, some like 60 degrees, 200 degrees, or whatever it may be, but we're talking about some numerical value. And so when you're talking about numbers like 61 degrees or 17 degrees, you can add, subtract, multiply, and divide them. So I'm taking this number plus that number, and they're going to equal to 180. Well, if that's the case, if two angles sum up to be 180 degrees, they are called supplementary. So right here, this next definition, supplementary angles sum up to 180 degrees. Supplementary angles sum up to be 180 degrees. So we're still on A. There's a lot going on in this part A. So not only do we have a pair of adjacent angles, they share a vertex, share a ray, and no common interior points, but these also sum up to be 180 degrees, which they're supplementary. So when this happens, the fact that these two lie on the same line, or they make up this line, and they're adjacent and they're supplementary, we call this pair, these two angles, a linear pair, because they form a line. That makes sense, right? When you hear pair, you think of two, and when you hear linear, I hope you think of line. So our next new vocabulary term is a linear pair. And a linear pair is a pair of adjacent angles. So you know what adjacent angles from up here. Common vertex, common ray, no common interior points. So they got to be adjacent, and they also have to be supplementary. A description of a linear pair would be a pair of angles that fall on the same line, or that form that line. And so that's pretty easy to identify because the name makes sense. Pair meaning two, and linear meaning line. So it's you got a linear pair. Okay. Excuse me. I think that's all for item A. Let's jump over to item B. So again, the angles that we're going to be looking at for this part, I understand there are three rays, DA, DB, and DC, and there's also three angles. You have the two parts that make up the whole 90-degree angle, but right now we're going to be looking at the two acute angles that make up that 90-degree angle. So those two angles, they're adjacent. So I hope that you can recognize that these two angles here are adjacent. They share ray DB, and they also have the same vertex, point D. So they are adjacent. They have, excuse me, their measurements. So let's talk about their measurements. The measurement of angle ADB? Well, we know that they're both acute, so both of these measurements are going to be less than 90 degrees, but let's go further and say that when we add the measurement of angle ADB with the measurement of the other angle that it's adjacent to, angle BDC, when we add those together, their sum is going to be 90 degrees, which conveniently leads me into our next term, complementary angles. Complementary angles are angles that sum up to 90 degrees. And I'm going to put in here, I'm just going to add in, it's two angles that sum up to be 90 degrees. And same thing with supplementary, that's two angles that sum up to be 180. So you have supplementary that angles that add up to be 180, and now you have complementary angles that sum up to be 90. Moving on, I want to go down to C. First off, you can say that these are non-adjacent. Obviously, non-adjacent. They don't share a vertex. They don't share a ray. So these are obviously non-adjacent. But when you look at their measurements, so I can say, hey, the measurement of angle DEF plus the measurement of angle RST, that's got to equal to 90 degrees, so therefore they are complementary. So these two angles are complementary. There's also another thing that you can do with these two angles. Since we know what the numerical value is, since this is 30 degrees and that's 60 degrees, we can also go a little bit more in depth in their measurements. We can say that the measurement of angle RST, which we know is 60, we can say that that is equal to 2 times the measurement of angle DEF. So again, this thing right here, the measurement of angle RST, that's just representing a number. This is a variable. It's a big, ugly, nasty variable, but it is. This is representing currently 60 degrees. So 60 degrees is equal to 2 times 30. And that's a true statement. 60 is 2 times 30. So we can create a little bit more detailed equations when we know the measurements. So yeah, those sum up to be 90 degrees, but also now we know that one is twice as big as the other. Moving down to these, again, this is an example of non-adjacent. We can, since we have the measurements of these two angles, angle DEF, which is 30 degrees, well, if we add that to the measurement of the other angle, XYZ, we can see that their sum is 180 degrees. So that implies they are supplementary. These two angles are supplementary. We can go beyond that too, since we know that this is 30 degrees and that's 150. I can say that the measurement of angle XYZ is equal to 5 times the measurement of angle DEF. And so there's an equation that just gives a little bit more characteristics of these two angles, talks about their properties. So a lot of very important stuff. Just recognizing adjacent angles need to have that common vertex, and so in part B they share this point D, and then they also share a ray. There's no overlapping of the two adjacent angles, meaning there's no common interior points. So please be aware of adjacent angles. When you happen to have adjacent angles that are also supplementary, which means they add up to be 180, that is called a linear pair. Those are going to come up a whole lot. These are so important. You must know what a linear pair is. Or if you have two angles that add up to be 90 degrees, like part B and part C, then those are called complementary angles. Moving on to the next page, page 8. It gives us a little reminder that hopefully you've already written down. It says, recall that the sum of the measures of complementary angles is 90 degrees, and then the sum of the measurements of supplementary angles is 180 degrees. I'm not one to come up with or teach tricks on how to memorize things. That's just not the way I tick. But if I hear about a good one, I try to share it, because I know some people do tick that way and work that way. So one student, this helped them last year, and it said that they wrote out the two new terms, supplementary and complementary, and then they would turn the first two letters, so in complementary CO and in supplementary SU, they would turn those first two letters into the sum of the angles, whatever they're describing. So complementary angles, the sum is 90. So she would change the first two letters into 90 by simply adding a line there. So you have 90. So that helped her memorize that complementary angles were 90 degrees. And then she took supplementary. She added a 1 in the front. She turned that S into an 8, and then turned that U into an O. So it looked like 180. So if that helps you, then please use that. But highlight this, star this, do whatever you got to do. Cannot forget what supplementary and complementary angles are. Item 3 says, the figure below shows two intersecting lines. So this is the diagram that they're talking about. Whenever you have two intersecting lines, they intersect at exactly 1 point. You did that in Algebra 1. This should not be a foreign concept here. When you did systems of equations and you solved them by using substitution or elimination or graphing, we know that if two lines are non-parallels or non-parallel lines, they'll intersect at exactly 1 point. So when this happens, when you have two lines that intersect, that point at which they intersect becomes the vertex of 1, 2, 3, 4 angles. So we will see this happen quite often in this class. And there's a lot of things going on in this diagram. So let's answer these questions. 3A says the figure below shows two intersecting lines. Name two angles that are supplementary to angle 4. So we know that supplementary means that they sum up to be 180 degrees. And what we're going to be identifying is two linear pair. So angle 4 here, when we take angle 4, which angle are we going to add to it to get 180 degrees? And the only correct answer is 3, because you have angle 3 and angle 4. And then also, when you take angle 4 and you add it to angle 5, you're also going to get 180 degrees. So I can say that the measurement of angle 3 plus the measurement of angle 4 is equal to 180 degrees. Those are a linear pair. They're going to form this line right there. I can also say that the measurement of angle 5 plus the measurement of angle 4 is also going to equal 180 degrees, because here they form this line. And so those two must be supplementary. Since those angles are adjacent and they are supplementary, those are a linear pair. There's two other linear pair in this diagram. You have 5 and 6, and you also have 6 and 3. So there are 4 linear pair when this situation happens, when you have two lines that intersect, forming those 4 angles.